Hello there, and welcome to the Science for Sleep channel. It's truly wonderful to have you here with us tonight. Whether you've arrived intentionally or simply drifted in while searching for something calm and comforting, you are very welcome. This channel is a place for gentle discovery, quiet curiosity, and peaceful reflection. Tonight, we'll be exploring forests, some of the most extraordinary and mysterious places on Earth. Forests are not merely large collections of trees standing side by side. They are living, breathing systems, vast and complex, working quietly every moment of the day and night. They inhale carbon dioxide and exhale oxygen, shaping the very air we depend on with every breath we take. They grow slowly, layer by layer, root by root, leaf by leaf, forming ecosystems that support life on a massive scale. Some forests are so vast and interconnected that they generate their own weather patterns, influencing rainfall, temperature, and even wind far beyond their borders. Within these forests stand trees that have been alive for thousands of years, some growing long before the pyramids of Egypt were built, before written history began. Beneath the soil, hidden from human sight, secret fungal networks stretch outward like living threads, allowing trees to exchange nutrients, send warnings, and quietly whisper to one another across the darkness underground. In the Amazon rainforest, more species of plants and animals live together than anywhere else on the planet. In the frozen taiga, sometimes called the boreal forest, trees stretch across entire continents, storing more carbon than all the world's oil reserves combined. And in the misty heights of cloud forests, water doesn't always fall as rain. Instead, it condenses directly from the sky and drips gently onto leaves and branches. Forests are ancient, they are powerful, and they are endlessly surprising. Tonight, we'll wander together through 100 fascinating truths about them. If you enjoy these gentle journeys through science and nature, you're welcome to like and subscribe, or to share a few thoughts in the comments. It helps others find their way here too, one sleepy soul at a time. But for now, there's nothing you need to do at all. Let your shoulders soften. Let your breathing slow and settle into its own natural rhythm. Imagine the hush of a forest at dusk, as daylight fades and the canopy above closes gently, filtering the last light of evening. And when you're ready, let's begin. The world's largest living organism is not an animal or a towering tree, but a forest fungus. Hidden beneath the soil of Oregon's Blue Mountains lies something almost impossible to imagine. At first glance, the forest floor looks ordinary. Trees standing quietly, fallen leaves scattered across the ground, pine needles carpeting the earth. Yet beneath this familiar surface stretches the vast body of a single organism. Long, thread-like structures weave through the soil, forming a living web beneath the forest. This organism, known as Armillaria astoi, covers an area of nearly 4 square miles and is believed to be thousands of years old. Although small mushrooms briefly appear above ground, the true body of the fungus exists below the surface. It is formed from an underground lattice of microscopic filaments called mycelium. These filaments spread slowly through the soil, connecting roots, absorbing nutrients, and expanding steadily over centuries. Scientists consider it the largest living organism on Earth, far larger than any whale, any tree, or any coral reef. What makes it especially astonishing is not only its size, but its quiet persistence. Year after year, it grows unseen beneath the forest, reminding us that some of the most immense forms of life exist entirely out of view. The Amazon rainforest alone holds 10% of all known species on Earth. Often described as the crown jewel of the planet's ecosystems, the Amazon stretches across 9 countries and supports an extraordinary abundance of life. 1 in every 10 species known to science makes its home within this vast green expanse. Millions of plants, animals, insects, and fungi coexist beneath its towering canopy. Jaguars move silently across the forest floor, while pink river dolphins glide through winding waterways. Entire colonies of ants cultivate underground gardens of fungus, while orchids cling delicately to branches high above the ground. Scientists believe that thousands, perhaps even millions, of species remain undiscovered within the Amazon's depths. The rainforest is not just diverse. It is dense with life, layered from its dark, nutrient-rich soil to its sunlit canopy. To walk within it is to step into a living encyclopedia of Earth's biology, unfolding leaf by leaf, sound by sound. The boreal forest stores twice as much carbon as all the world's oil reserves, stretching like a vast green crown across Canada, Russia, and Scandinavia. The boreal forest may not receive as much attention as the Amazon, but its influence on the planet is immense. Beneath its forests of spruce, pine, and larch lies a massive storehouse of carbon. Much of this carbon is locked away in cold soils, wetlands, and slow-decaying layers of moss and peat. Scientists estimate that the boreal forest contains nearly twice as much carbon as all known oil reserves combined. This makes it one of Earth's most important natural defenses against climate change, quietly absorbing and storing carbon for centuries. However, rising temperatures are beginning to thaw permafrost, risking the release of this ancient carbon back into the atmosphere. In many ways, the boreal forest is like a vault, and the future of Earth's climate depends on keeping that vault sealed. The Amazon rainforest produces its own rain. While many imagine rainforests receiving storms from distant oceans, the Amazon creates much of its rainfall itself. Each day, countless trees draw water from the soil and release it into the air through tiny pores in their leaves. This process, known as evapotranspiration, fills the atmosphere with invisible moisture. As this moisture rises, it forms clouds that eventually release rain back over the forest. A single large tree can release hundreds of gallons of water in a single day. This continuous cycle sustains the forest, fuels rivers, creates thunderstorms, and even sends moisture thousands of miles away, influencing rainfall in distant regions such as the U.S. Midwest. The Amazon is a self-sustaining engine of life, a forest that drinks and rains in the same breath. Some trees communicate through underground fungi. Beneath the soil of nearly every forest lies a hidden communication network made of fungal threads linking tree roots together. Scientists often call this network the wood wide web. Through it, trees share nutrients, exchange chemical signals, and respond collectively to threats. A shaded sapling may receive sugars from a larger neighboring tree. A tree under attack from insects may send warning signals that help others strengthen their defenses. Some older trees even act as mother trees, directing resources toward younger seedlings. Though this communication is not conscious or spoken, it represents a deep form of cooperation carried out molecule by molecule beneath the ground. What appears to be a silent forest is, in truth, alive with constant exchange. The oldest known trees began growing before the pyramids were built. In the mountains of California and Nevada, high above desert valleys, stand bristlecone pines whose lifespans stretch back nearly 5,000 years. These twisted, weathered trees are the oldest known individual living organisms on Earth. They were already ancient when the first pyramids were rising in Egypt. They have survived countless droughts, fires, freezing winters, and the rise and fall of civilizations. Their secret lies not in rapid growth, but in extreme slowness. They grow so gradually that even after thousands of years, many remain relatively small. Their dense, resin-rich wood resists decay, allowing them to endure through millennia. To look at a bristlecone pine is to witness living history, a reminder that time moves very differently for trees. The Amazon may be approaching a point of collapse. Despite its immense size, the rainforest is fragile. Scientists warn that ongoing deforestation and climate change may push it toward a dangerous tipping point. As rainfall decreases and temperatures rise, parts of the forest could transition into a savanna-like ecosystem. This would result in fewer trees, reduced rainfall, and a breakdown of the forest's self-sustaining cycles. Already, some regions of the Amazon emit more carbon than they absorb, a stark reversal of its long-standing role as a carbon sink. If the forest crosses this threshold, billions of tons of stored carbon could be released into the atmosphere, accelerating global warming and threatening countless species. The collapse of the Amazon would reshape not only South America, but the entire planet's climate system. The Congo rainforest holds more carbon than the entire United States emits in a decade. Second in size only to the Amazon, the Congo rainforest is often overlooked, yet its role in stabilizing Earth's climate is enormous. Beneath its dense canopy and vast peatlands lies one of the planet's largest carbon reserves, storing more than 80 billion tons of carbon. Much of this carbon is trapped in waterlogged peat soils, where low oxygen slows decomposition. However, rising temperatures and human disturbance threaten to dry these peatlands. Scientists warn that if this carbon is released, the consequences would be catastrophic. For now, though, the Congo rainforest stands as one of Earth's most powerful protectors, a vast green fortress quietly holding back the rising tide of climate change. Its towering trees, dense undergrowth, and waterlogged soils work together like a living shield, absorbing immense amounts of carbon and storing it safely within wood, leaves, and peat. Though often overlooked compared to the Amazon, the Congo's quiet strength plays a critical role in stabilizing the planet's atmosphere, buying humanity precious time in a warming world. The tallest trees on Earth rise higher than a football field is long. If you stand at the base of a coastal redwood in California and slowly crane your neck upward, the tree simply seems to keep going, stretching farther than your eyes can comfortably follow. These giants, some exceeding 370 feet in height, are the tallest living organisms ever to grow on land. To imagine their scale, picture a football field standing upright, and then imagine the tree rising even higher than that. High above the forest floor, their crowns sway in winds no human can feel from below. Entire ecosystems exist in these upper branches, where ferns, mosses, insects, and even small salamanders live their entire lives without ever touching the ground. Coastal redwoods grow in fog-shrouded groves along the Pacific coast, where ocean mist rolls inland each day. Rather than relying solely on rain, these trees drink moisture directly from the air, their needles capturing fog droplets that trickle down to their roots. Despite their immense size, redwoods are fragile, surviving only within a narrow band of climate where temperature, moisture, and fog remain just right. Still, they stand as reminders of nature's ability to reach skyward, stretching toward the clouds in a quiet feat of endurance unmatched anywhere else on Earth. Redwoods can live for more than 2,000 years. They are not only the tallest trees on the planet, but also among the longest lived. Some individual redwoods have stood in the same place for 2 millennia, silently witnessing the rise and fall of civilizations, the passing of generations, and the slow reshaping of landscapes around them. Their bark, thick and fibrous, acts as natural armor, resisting insects and insulating the tree from fire. When wildfires sweep through redwood forests, flames often clear away competing vegetation while leaving the redwoods standing. Their roots, surprisingly shallow for such massive trees, spread outward and intertwine with those of neighboring redwoods. Together, they form an interlocked network that stabilizes the entire grove. In this way, a stand of redwoods becomes more than a collection of individual trees. It becomes a single ancient community, bound together beneath the soil. Walking among them can feel like entering a living cathedral, where massive pillars rise into drifting mist and time itself seems to slow. Their presence reminds us that endurance, patience, and quiet strength can leave marks measured not in moments, but in centuries. Cloud forests drink directly from the sky. High in mountainous regions where mist rolls constantly over the treetops exist forests unlike any others on Earth. These cloud forests are wrapped in fog for much of the year, and the trees there have evolved remarkable adaptations to survive. Their leaves, branches, and thick coverings of moss act like natural nets, combing moisture from drifting clouds. Tiny droplets collect and drip steadily to the forest floor, even when no rain falls. This ability allows cloud forests to thrive in places where rainfall alone would not be enough. The water they capture often feeds streams and rivers that flow down into valleys far below, supplying fresh water to ecosystems and human communities alike. To walk through a cloud forest is to move inside a living cloud, where every surface glistens, the air feels heavy with moisture, and the forest's heartbeat seems woven directly into the mist itself. Some forests glow at night with bioluminescent life. Step into certain forests after dark, and you may witness something that feels almost unreal. Tiny mushrooms scattered across decaying logs emit a soft green glow, like lanterns lit by nature itself. This phenomenon, known as bioluminescence, is caused by chemical reactions within the fungi. Scientists believe the glow may attract insects, which then help spread fungal spores to new locations. In tropical forests, entire patches of undergrowth can shimmer faintly, transforming the forest floor into a scene that looks like a reflection of the stars above. Fireflies add to this display, flashing among branches like drifting sparks. For centuries, people have described such glowing forests as enchanted or magical. Today, scientists study the chemistry behind this light, seeking to understand why some species evolved this trait while most did not. To the human eye, however, it still feels like magic, a quiet reminder that forests can shine even after the sun has set. Some forests burn regularly as part of their natural cycle. While fire may seem purely destructive, in many ecosystems it is essential. In places such as North America's pine forests or Australia's eucalyptus groves, fires sweep through every few years. These fires clear away dense underbrush, recycle nutrients into the soil, and create space for new life. Certain pine species produce cones sealed with resin that only melt open under intense heat. Without fire, these trees would be unable to reproduce. After flames pass, the ash-rich soil becomes the perfect environment for new growth. Animals, too, have adapted. Some birds follow fires, hunting insects fleeing the smoke. Problems arise when humans interrupt this natural cycle through suppression or land misuse, allowing fuel to build up until fires become unnaturally intense. In their natural rhythm, however, forest fires are not an ending, but a reset, a chance for the ecosystem to breathe, renew, and begin again. Fires can trigger seeds to sprout in forests. In the aftermath of a blaze, the landscape may appear lifeless and blackened. Yet beneath the ash lies a hidden promise. Some seeds have waited for years, even decades, for the signal that only fire can provide. Species such as lodgepole pines or Australia's banksia have seeds that open only under extreme heat. Others respond to chemicals found in smoke, which act as a message that competition has cleared and sunlight can finally reach the soil. Within weeks of a fire, green shoots often blanket the forest floor, signaling the start of a new generation. Fire, then, is not just destruction, it is a catalyst for renewal. It clears space, unlocks seeds, and allows life to begin again. The cycle of life and death in many forests is written quite literally in flame. Certain trees can survive being struck by lightning. When lightning tears through a forest, the sound and force can be terrifying. Trees often take direct hits, splitting or igniting in an instant, yet some survive. Thick, insulating bark can guide electricity safely along the outside of the trunk, protecting the living tissue within. Moisture inside the tree can also help conduct the current quickly downward. Over time, trees may heal around lightning scars, leaving dark, spiraling streaks etched into the bark like permanent signatures of the storm. These scars stand as silent records of survival. Trees that endure lightning strikes become symbols of resilience, standing tall even after nature's most powerful forces have tried to bring them down. In the taiga, trees can explode in extreme cold. The taiga, the largest forest on Earth, spans Siberia, Canada, and Scandinavia. Winters here are brutally cold, with temperatures sometimes plunging below -60 degrees Fahrenheit. In such conditions, tree sap can freeze so rapidly that it expands faster than the trunk can withstand. The result can be a sudden rupture, producing a loud crack that echoes through the forest like gunfire. In rare cases, parts of the tree may burst outward, giving rise to the description that trees can explode in the cold. While many trees have adaptations such as antifreeze-like chemicals in their tissues, these defenses are not always enough. The exploding trees of the taiga are reminders of how harsh this biome truly is, a place where survival pushes every living thing to its limits. Some forest fires burn underground for years. Not all fires disappear when flames fade from sight. In forests with peat-rich soils, fires can smolder slowly beneath the surface, hidden from view. These underground fires, sometimes called zombie fires, creep through layers of carbon-rich peat for months or even years. They can survive beneath snow through winter, only to re-emerge in spring and reignite surface fires long after a wildfire season seems to have ended. These hidden blazes release enormous amounts of carbon into the atmosphere and are notoriously difficult to extinguish. Because they burn deep beneath the surface, water poured from above rarely penetrates far enough to reach the smoldering layers below. Firefighters may see no flames at all, yet the ground itself remains hot and alive with slow-burning embers. The smell of smoke can linger in the air for miles, drifting across towns and forests alike, puzzling residents who see no visible signs of fire. These are fires that never quite die, lingering quietly beneath the soil, smoldering reminders that forests can hold on to both life and destruction far longer than we often realize. Forests can even generate their own lightning. They do not merely endure lightning strikes from passing storms. In many cases, they actively help create the conditions that give rise to them. As sunlight warms leaves during the day, vast quantities of water vapor rise from the forest canopy into the atmosphere. This moisture feeds towering storm clouds above. Inside those clouds, tiny particles of ice and water collide and swirl, gradually building powerful electrical charges. Dense, humid forests such as the Amazon are especially effective at fueling this process, releasing staggering amounts of moisture into the air each day. The result is frequent lightning activity, sometimes thousands of strikes in a single night across the basin. Some studies even suggest that aerosols released by trees may influence how storm clouds form and how intensely they behave. In this way, forests are not passive victims of lightning, but active participants in creating the atmospheric drama above them. Each flash across the sky and each rolling thunderclap can be traced, in part, back to the slow and steady breathing of countless leaves below. Some forests remain green even through ice ages. During periods when massive glaciers covered much of the northern hemisphere, it might seem impossible that forests could survive at all. Yet pockets of trees endured. In regions shielded from the harshest cold, isolated groves of evergreen forests managed to persist even as ice advanced from the poles. These refugia became sanctuaries of green life in an otherwise frozen world. When the glaciers eventually retreated, these surviving forests spread outward again, reseeding vast regions of Earth. Today, genetic studies of trees reveal clues to these ancient refuges, tracing lineages that stretch back tens of thousands of years. The survival of these forests explains why so many tree species still exist today. Without them, much of Earth's forest life may have vanished forever. Their persistence is proof that even in the harshest eras, life finds cracks in the cold where it can endure. There are fossilized forests buried beneath the ice of Antarctica. Though today it is a land of snow and silence, Antarctica was once green. Over 200 million years ago, before continental drift carried it into its frozen isolation, the land lay closer to the equator and supported vast forests. Fossil evidence reveals preserved stumps, roots, and entire petrified trunks hidden beneath layers of rock and ice. Some discoveries suggest dense polar forests that endured months of continuous darkness during winter and endless daylight during summer. Scientists drilling deep into Antarctic rock uncover leaf impressions, fossilized wood, and traces of ancient soils, remnants of a lost world. These discoveries reveal just how dramatically Earth's climate and continents have shifted over time. To imagine forests standing where glaciers now dominate is to glimpse a planet in constant motion, reshaping itself across millions of years, where even the coldest places once teemed with green life. The Amazon River once flowed backward, changing its forest forever. Today, the river pours eastward into the Atlantic Ocean, carrying more water than any other river on Earth. But millions of years ago, it flowed in the opposite direction, westward toward the Pacific. As the Andes Mountains rose, geological forces gradually blocked the river's path. Over immense spans of time, the Amazon reversed its flow. This transformation reshaped floodplains, altered ecosystems, and permanently changed the forest. Sediments and nutrients were redistributed, enriching soils and creating fertile conditions that would support extraordinary biodiversity. New habitats emerged, driving evolution across countless species. Without this reversal, the Amazon rainforest as we know it would never have existed. It stands as a reminder that even the greatest rivers are not fixed, but bend and shift to the planet's deeper rhythms, giving rise to entire worlds of life. Some forests are so wet that rain never reaches the ground. In certain rainforests, the canopy overhead is so dense that rainfall is captured almost entirely before it can fall to the soil. Leaves and branches intercept the water, holding it high above the forest floor in a suspended world of moisture. Epiphytes, plants that grow on trees instead of in soil, thrive in this environment, drawing water directly from rain and mist. For many animals, this upper canopy becomes a complete habitat, filled with pools, dripping moss, and miniature streams. Scientists who climb into these heights often describe it as stepping into an entirely separate ecosystem, one that floats above the forest below like a hidden continent. Down on the ground, the soil may remain dry for days even while storms rage overhead. These forests show that rain does not always fall. Sometimes it is caught and cradled long before it ever touches the earth. Rainforests can create thunderstorms. Thunder rolling over tropical forests does not always come from distant weather systems. In places like the Amazon, the forest itself fuels the storms. Through evapotranspiration, trees release enormous amounts of water vapor into the sky. This moisture rises, forming thick clouds that grow increasingly unstable throughout the day. By afternoon, the buildup often erupts into thunderstorms filled with lightning, heavy rain, and booming thunder. These storms complete a powerful cycle. Rain feeds the trees, which then release more vapor, sustaining the pattern. The scale is astonishing. The Amazon alone releases billions of tons of water into the atmosphere each year, enough to sustain its own weather system. In this way, the rainforest is not just shaped by climate, it actively creates it. Forests can create their own winds. Wind is often thought of as a global force driven by oceans and large-scale atmospheric circulation. Yet forests, especially vast ones, can generate their own airflow. As sunlight warms the canopy, heated air rises upward, pulling cooler air from surrounding areas inward. This movement creates steady local breezes that circulate through the forest. In massive rainforests, these winds can grow strong enough to influence regional weather patterns. Leaves play a role as well. Their rough surfaces slow air movement, creating turbulence that mixes and stirs the atmosphere. The result is a forest that does not simply sit beneath the weather, but actively shapes it. Stand in a forest clearing and you may feel it. A gentle breath born not from distant oceans or skies, but from the living machinery of trunks and leaves around you. Tropical forests breathe out vast rivers of water vapor. Forests do not only exchange oxygen and carbon dioxide, they also breathe water. Each day, a single large tropical tree can release hundreds of gallons of water vapor into the air. Multiply that by billions of trees, and invisible rivers begin to flow through the atmosphere above the canopy. In the Amazon, these atmospheric rivers stretch for thousands of miles, carrying moisture far beyond the forest itself. They help drive rainfall across entire continents and influence weather in regions far removed from the jungle. This process supports agriculture, ecosystems, and climate stability across much of the world. The forest's breath, though unseen, touches lives far beyond its borders. Scientists often describe the Amazon rainforest as a vast, living humidifier, endlessly pumping life-giving moisture into the sky above it. But this comparison barely captures the scale of what is happening. Every tree rooted deep in the soil stretches upward into the air, blurring the boundary between earth and atmosphere. Their leaves act like countless tiny valves, opening and closing, releasing invisible breaths of water vapor into the air. This quiet exhalation, repeated billions of times across the forest, becomes one of the most powerful forces shaping the planet's climate. Though unseen, the collective breath of the forest rises high above the canopy, feeding clouds, influencing winds, and sustaining rainfall patterns far beyond the forest's borders. Certain forests do more than release water vapor. They also emit microscopic particles known as aerosols, which play a surprisingly important role in the formation of clouds. These aerosols originate from plant chemicals, soil bacteria, fungal spores, and even tiny microorganisms that drift upward on warm air currents. Once in the sky, these particles become the seeds around which water droplets gather. Without them, clouds would struggle to form at all. Some of these moisture-laden clouds may travel thousands of miles before finally releasing their rain, sometimes over entirely different continents. In this way, a forest's breath does not stop at its edges. Moisture and influence carried from the Amazon, for example, has been traced across the Atlantic Ocean, subtly shaping rainfall patterns far away. Scientists are still unraveling the exact chemistry behind these processes, but the principle is unmistakable. Forests extend their reach far beyond their roots, weaving themselves into the global water cycle. Cloud by cloud and drop by drop, distant places become connected through invisible threads of air. The familiar scent of pine trees offers another glimpse into how forests quietly shape the atmosphere. That sharp, clean fragrance experienced on a cool forest walk is not just pleasant. It is chemistry unfolding in real time. Pine trees release organic compounds known as terpenes, responsible for their distinctive smell. Once these molecules drift into the air, they interact with sunlight and other atmospheric chemicals, forming tiny particles that can influence how clouds develop. These reactions can alter the way sunlight scatters in the atmosphere, sometimes reflecting heat back into space and contributing to a slight cooling effect. In this sense, the smell of pine is not merely a sensory pleasure but part of a vast atmospheric process. To breathe it in is to participate in a cycle that stretches from forest floor to sky, from a quiet woodland trail to the delicate balance of Earth's climate system. Even scent, it turns out, can shape the world. Forests also cool entire regions, sometimes by several degrees. Anyone who has stepped into a forest on a hot summer day feels the change immediately. Shade explains part of it, but the deeper cooling comes from transpiration. As trees release water vapor, heat is absorbed during evaporation, lowering the surrounding air temperature. This natural air conditioning creates stable microclimates essential for wildlife, plant growth, and human comfort. On a larger scale, massive forests like the Amazon cool entire regions, influencing weather systems and stabilizing climates over vast areas. Cities bordered by forests often experience lower temperatures than those surrounded by bare land. In an increasingly warming world, this cooling effect is no longer just refreshing. It is vital. Forests act as natural thermostats, regulating heat through steady, silent processes. Every leaf that rustles in the breeze contributes to this balance, making forests not just green sanctuaries, but living systems that ease the planet's growing fever. Remarkably, forests even help keep the planet's poles frozen. Though it may seem counterintuitive, tropical and temperate forests influence atmospheric circulation patterns that stretch across hemispheres. The heat and moisture they release affect global wind systems, which in turn influence how warmth is distributed toward the polar regions. Forests also store enormous amounts of carbon, keeping greenhouse gases out of the atmosphere. Without this storage, polar ice would warm and melt far more rapidly. Even boreal forests near the Arctic play a direct role by insulating permafrost and shading snow. The fate of the poles is therefore closely tied to the fate of forests. What happens in Earth's green belts ripples outward to its frozen edges. Protecting forests helps protect ice, oceans, coastlines, and ultimately the stability of the entire planet. Earth is a web. Tug one strand and even the poles can shiver. Forests also influence global wind patterns. They do not simply stand beneath the atmosphere. They actively shape its movement. As forests pump water vapor upward, they create subtle pressure differences that help drive winds across continents. This process, sometimes called the biotic pump, may help draw moist air inland from the oceans. Without it, many interior regions could dry into deserts. Research suggests forests influence air circulation on a global scale, altering storm paths and even jet streams. The gentle swaying of leaves in one place can ripple outward, shaping weather thousands of miles away. Winds that carry rain to distant farmlands or steer storms across oceans may owe part of their journey to the silent labor of trees. Forests are not passengers in Earth's climate system. They are pilots guiding the flow of air itself. Some trees also release chemicals that directly affect the human mind and body. If you've ever felt calm while walking through a forest, science suggests it may not be imagination. Trees emit airborne compounds known as phytoncides, which help protect them from insects and disease. When humans inhale these chemicals, studies show they can lower stress hormones, reduce blood pressure, and even enhance immune system activity. This is one reason forest bathing, a practice that originated in Japan, is now recognized as a therapeutic activity. Breathing the scents of pine, cedar, or cypress changes body chemistry in measurable ways. Forest air is not just oxygen-rich. It carries subtle medicine. Trees defending themselves end up soothing us, revealing how deeply human biology remains tied to natural environments. Sound plays a powerful role as well. Close your eyes in a forest and sound becomes the dominant sense. Leaves whispering in the wind, birds calling across branches, insects humming, water dripping softly from canopy to ground. Research shows that these natural soundscapes can significantly reduce cortisol, the body's main stress hormone. Unlike mechanical noise, forest sounds are rhythmic and layered, patterns the brain interprets as safe. This calms the nervous system, slows heart rate, and deepens breathing. Some hospitals now use forest recordings to aid recovery, and urban designers study how natural soundscapes might improve city life. Still, nothing matches the real experience. The living chorus of a forest feels like a reset for the mind, reminding us that healing does not come from silence, but from nature's quiet conversations. Forests can even change the color of the atmosphere itself. On hazy summer days, a soft bluish tint often appears over vast forested landscapes. This glow is not an illusion. It is sunlight scattered by organic compounds released by trees, especially pines. These particles interact with light, painting the air with subtle color and reminding us once more that forests do not merely exist beneath the sky. They shape it. The scattering shifts the color of the air, giving it a faint blue cast. This subtle but powerful effect is the reason entire mountain ranges can appear washed in blue tones, even from great distances. In the Appalachian Mountains, this phenomenon is so strong and so consistent that the range earned the name the Blue Ridge. What you are seeing is not simply distance, fog, or ordinary haze. It is the breath of trees themselves, released invisibly into the atmosphere, altering the way light bends, scatters, and spreads as it travels toward your eyes. Forests quite literally tint the air around them, reshaping how landscapes are perceived. Every shimmering ridge in the distance, every soft, mist-covered horizon, is influenced not only by rock and sky, but by countless leaves releasing organic compounds into the air. The forest does not just sit beneath the atmosphere. It actively paints it. The nighttime forest sky can glow with invisible radiation. Step into a forest at night and the darkness may feel deep and complete, as if the world has been wrapped in silence and shadow. Yet above the canopy, the sky itself can glow faintly, not with visible starlight or moonlight, but with radiation beyond the range of human sight. Earth's atmosphere naturally emits faint bands of energy known as airglow, created by chemical reactions high above the planet's surface. In forested regions where artificial light is scarce, this glow becomes more detectable with sensitive instruments. To certain insects and nocturnal animals, these emissions may not be invisible at all. They may shape navigation, movement, and behavior in ways humans are only beginning to understand. In this way, the nighttime forest sky is never truly dark. It hums quietly with hidden energy, wrapped in a glow our eyes cannot see. For humans, this adds another layer of mystery to nights beneath the trees, a reminder that even in darkness, light still flows overhead just beyond our perception. Forest air is filled with microscopic particles from trees. Every breath you take in a forest contains far more than oxygen alone. The air is rich with microscopic particles released by leaves, bark, soil, and roots. Droplets of water vapor drift invisibly. Fragments of organic compounds float on the breeze. Spores and pollen ride the currents between branches. These particles act as messengers of the forest, rising upward to influence cloud formation or settling back into the soil to continue the cycle of life. Some even serve as the seeds around which raindrops form, meaning the air above a forest helps decide when and where rain will fall. For humans, breathing this air often feels cleaner and lighter than urban air, in part because these natural aerosols help bind and remove pollutants. To breathe forest air is not just to inhale oxygen, but to join a living exchange of chemistry and biology that makes the forest far larger than the trees alone. A single teaspoon of forest soil contains billions of organisms. Beneath the carpet of fallen leaves and moss lies a hidden universe we rarely notice. Scoop up just 1 teaspoon of forest soil and you hold billions of microscopic lives. Bacteria, fungi, protozoa, and tiny nematodes thrive in the damp darkness, breaking down fallen wood and leaves, recycling nutrients, and feeding the roots above. Many of these organisms remain unknown to science, their functions still a mystery. Yet together, they form the foundation of the forest's health. They shape soil structure, defend trees against disease, and make growth possible. Without them, the towering canopy overhead would collapse. In many ways, the greatest diversity of a forest is not found in birds or mammals, but in the unseen world beneath our feet. Every step across the forest floor crosses an invisible galaxy of life, buzzing with activity too small to see, yet essential to everything above. The forest floor breathes carbon in daily rhythms. Forests do not only breathe across seasons or years, they inhale and exhale every single day. At night, when photosynthesis pauses, soil microbes and roots release carbon dioxide, allowing it to build just above the ground. By day, sunlight powers leaves to draw that carbon back in, lowering its concentration again. This rhythm is so precise that scientists can determine the time of day in a forest simply by measuring carbon levels. In a sense, the entire ecosystem keeps a heartbeat synchronized with the sun. Each day is marked by pulses of breath. These shifts remind us that forests are not static scenery, but living systems in constant motion. The quiet breathing of soil and leaves, unseen yet unending, underlies every sound beneath the canopy. Insects may outnumber leaves in some forests. Leaves seem endless, carpeting branches and littering the ground. Yet in some tropical forests, insects outnumber them. Ants march in vast armies. Termites build towering mounds. Beetles of every color and shape scurry across bark and soil. Scientists estimate that a single hectare of rainforest can contain over 40,000 insect species, with countless individuals occupying every layer of the ecosystem. Many have never been named or studied. These insects are not background noise. They pollinate plants, recycle nutrients, and feed countless animals. Without them, the forest would unravel. Their sheer numbers make them the true undercurrent of life, a constant movement that holds the ecosystem together. Some forest plants trap and eat insects. Forests are filled with insects, but also with plants that prey upon them. Carnivorous plants like pitcher plants and sundews lure insects with sweet scents, vivid colors, or sticky surfaces. Once trapped, enzymes digest the prey, providing nutrients scarce in poor forest soils. In some tropical forests, pitcher plants grow large enough to trap frogs or small mammals. These strategies reveal how competition shapes survival. In shaded understories where sunlight is rare, plants adapt in astonishing ways. Watching a plant consume an insect is a glimpse into evolution's creativity, where survival rewrites the rules. Forests harbor viruses we've never discovered. Deep within soils, pools of water, and the bodies of animals and insects, viruses exist in numbers beyond imagination. Many remain unknown to science. Some regulate microbial populations. Others may hold genetic tools useful for medicine or technology. Forests are reservoirs of genetic diversity, and viruses are part of that archive. While some cause disease, many exist quietly, shaping ecosystems unseen. Beneath every leaf and root, invisible forces are at work. The canopy of a rainforest can be as dense as concrete. In tropical rainforests, the canopy can be so tightly woven that less than 1% of sunlight reaches the forest floor. Branches and leaves interlock high above, forming a living ceiling that filters light into a perpetual green twilight. Beneath it, life adapts to shadows, moisture, and patience. The forest above shapes everything below, proving that even light itself must negotiate with the living architecture of trees. In some places, the canopy is nearly impenetrable, with overlapping foliage acting like a living ceiling high above the forest floor. Layers of leaves, branches, and vines weave together so tightly that they form a continuous green barrier. Scientists have compared the density of this canopy to concrete, not because it is hard, but because it is so thick that water, falling debris, and even small animals often stop before ever reaching the ground. Rain can be intercepted again and again, dripping slowly from leaf to leaf, sometimes evaporating before it touches the soil at all. This living shield protects the understory below, keeping it cooler, darker, and far more humid than the open world above the treetops. Because of this separation, many plants and animals spend their entire lives in the canopy itself, never descending to the ground. For them, the treetops are the true forest, complete with winding rivers of vines, broad platforms of branches, hidden pathways of leaves, and a ceiling that feels less like open sky and more like endless green architecture stretching in all directions. Forest canopies can hold entire miniature worlds. High above the forest floor, a hidden realm thrives largely out of human sight. In the canopy, mosses, orchids, and bromeliads cling tightly to branches, forming hanging gardens that bloom in midair. These plants trap rainwater inside their leaves, creating tiny pools that never touch the ground. Within these miniature reservoirs live frogs, insects, mosquito larvae, and in some tropical forests, even small crabs that have adapted to life far above the soil. Ant colonies tunnel through branches, while spiders spin webs between leaves. Colorful birds dart through the light, and monkeys leap effortlessly from limb to limb. Scientists who climb into these aerial ecosystems often describe the experience as stepping into another planet. The canopy is so vast that it effectively doubles the surface area of the forest, creating layers of habitat stacked above one another like vertical landscapes. For centuries, this world remained unexplored, hidden beyond reach. Modern canopy research has revealed it to be one of the most diverse ecosystems on Earth, a reminder that forests are not flat spaces, but towering structures filled with life both above and below. Forest canopies contain more species than the forest floor. While it may seem intuitive that most life would exist at ground level, in rainforests the opposite is often true. The canopy teems with more species than the shaded forest floor beneath it. Insects, birds, reptiles, and mammals all find abundant food, shelter, and breeding grounds among the leaves. Many plants grow exclusively in this upper layer, anchoring themselves to branches and never touching soil at all. Scientists estimate that more than half of all rainforest species may live entirely in the canopy. The diversity is so immense that a single square meter of canopy can host more life than an entire meadow elsewhere. Some researchers even refer to the canopy as the real rainforest because it holds the majority of its organisms. For those that thrive there, the canopy is a vast city in the sky, crowded, busy, and endlessly resource-rich, while the forest floor below is merely another distant layer rarely visited. Forest floors rarely see more than 1% of sunlight. Beneath the towering canopy, the forest floor exists in near-perpetual shadow. In dense rainforests, only a tiny fraction of sunlight filters through the layers above, often less than 1%. This dim environment shapes everything that grows and moves there. Plants adapt by spreading broad, thin leaves to capture even the faintest light. Some species bloom directly on tree trunks, taking advantage of brief shafts of sun that slip through gaps. The cool, humid darkness is ideal for decomposers such as fungi, termites, and beetles, which break down fallen leaves and wood, recycling nutrients back into the soil. For some animals, the shadows offer protection from predators. For others, survival depends on heightened senses of smell, touch, or hearing. Though it may seem still and quiet, the forest floor is alive with constant motion, a shadowed stage where life adapts to thrive without light. Trees in dense forests may never see direct sunlight. In crowded forests, competition for light is relentless. Some trees grow rapidly, stretching straight upward in a race to reach the canopy before their neighbors. Others grow slowly in deep shade. Entire generations of saplings may live for decades beneath larger trees, never once touched by direct sunlight. They survive instead on faint, filtered light that trickles through the leaves above. Remarkably, many shade-tolerant species can wait patiently for years, even centuries, barely growing at all. When an older tree finally falls and sunlight floods the gap, these waiting saplings respond instantly, surging upward in a burst of growth. This quiet patience is built into the forest's life cycle. Even a fallen tree becomes an opportunity, opening space and light for the next generation to rise. Some forests are so dark they feel like night at noon. In certain rainforests, the canopy grows so dense that the forest floor remains dim even at midday. Travelers describe these places as hushed, shadow-filled, and otherworldly, where colors fade into deep greens and grays. In this twilight world, animals evolve extraordinary adaptations. Some insects and frogs glow faintly to attract mates. Larger animals rely more on sound than sight to navigate. The darkness keeps temperatures cool and humidity high, allowing decomposition to occur rapidly. What feels mysterious to humans is simply normal life for forest creatures. Here, noon and midnight can appear nearly identical, and time itself seems slowed beneath the constant shade. Some forests contain ancient human structures still hidden. Forests are not only homes for wildlife, but also guardians of human history. In the Amazon, advanced LiDAR scanning has revealed massive ancient cities buried beneath the trees, complete with roads, canals, and ceremonial platforms. In Cambodia, the ruins of Angkor were swallowed by jungle for centuries. Dense forests can hide temples, villages, and trade routes for millennia. Roots wrap through stairways, trees grow over walls, and moss softens stone until ruins blend into nature itself. Forests both preserve and conceal these traces, blurring the line between civilization and wilderness. There are entire ecosystems in forest tree hollows. A hollow in an old tree may seem insignificant, but to many creatures it is an entire world. Rainwater collects inside, forming tiny ponds that support insects, frogs, and microbes. Birds nest in these cavities, while bats and squirrels find refuge within. In tropical forests, tree hollows are so common they support entire communities. Each hollow becomes a self-contained ecosystem, proof that forests operate on every scale imaginable. Bamboo forests can grow taller than skyscrapers in just weeks. Bamboo, though technically a grass, can dominate forests with astonishing speed. Some species grow nearly a meter per day, forming dense groves that rise like green towers. These forests support animals such as red pandas and giant pandas, and humans rely on bamboo for food, building, and textiles. Walking through a bamboo forest feels like standing inside a living surge of growth, a reminder of nature's unmatched speed and power. The stalks rise straight and tall, stretching upward with incredible speed, their smooth surfaces brushing against one another as the wind passes through. As they sway, they creak softly, producing a rhythmic sound that feels almost musical, like nature playing its own wooden instruments. Walking among them, the air seems alive with motion and sound. This gentle orchestra is a reminder of the astonishing power of life when conditions are perfectly aligned. In the rainforest, warmth, moisture, and fertile soil combine to accelerate growth beyond what most landscapes can achieve. What takes decades elsewhere can happen in mere weeks here, transforming empty space into towering green architecture. Rainforest trees also display remarkable creativity in how they reproduce. In most forests, flowers bloom at the tips of branches high above the ground, accessible only to insects or birds that can reach the canopy. But in rainforests, many species use an entirely different strategy known as cauliflory, where flowers and fruits grow directly from the trunk itself. Thick bark becomes decorated with clusters of blossoms or heavy fruits, turning the tree into a living column of color and scent. This adaptation allows animals such as monkeys, bats, rodents, and even ground-dwelling mammals to access nectar and fruit without climbing into the upper branches. Pollination becomes more efficient, relying on creatures that move easily through the lower forest layers. Some of the rainforest's most important plants depend on this strategy. Cacao trees, the source of chocolate, produce their flowers directly on their trunks, where tiny insects and small mammals can reach them. The sight is striking. Delicate blossoms emerging straight from solid wood, or large fruits hanging like ornaments on a living pillar. This adaptation is perfectly suited to the dense, vertical world of the rainforest, where space is crowded and competition is intense. Cauliflory is a vivid reminder that plants are endlessly inventive, shaping their forms in response to the animals around them. In these forests, even the trunks themselves are alive with blossoms, turning the forest floor into an extension of the canopy's garden. The Amazon's trees release more oxygen than all the world's grasslands combined. The Amazon rainforest is often called the lungs of the earth, and while the phrase simplifies a complex system, it reflects a powerful reality. Every day, billions upon billions of leaves capture sunlight and perform photosynthesis, pulling carbon dioxide from the air and releasing oxygen as a byproduct. Grasslands cover vast areas, but their shorter plants simply cannot match the sheer scale of rainforest trees, some rising hundreds of feet into the sky and carrying millions of leaves each. The oxygen released by these forests circulates around the globe, blending into the atmosphere shared by all living creatures. Much of this oxygen is used again within the forest itself by animals, plants, fungi, and microbes, but the contribution remains immense. The Amazon demonstrates how deeply Earth's atmosphere is tied to the quiet, constant labor of trees. Forests breathe in carbon and breathe out life, hour after hour, day after day. Forests as a whole play a critical role in Earth's oxygen exchange. While oceans and plankton are major producers of oxygen, forests operate alongside them as stabilizers of the planet's breathing cycle. Layer upon layer of leaves absorb sunlight and manage carbon flows, keeping atmospheric systems resilient. Every breath we take is supported not only by the oceans, but by forests tirelessly converting sunlight into air. Some trees go even further in supporting life by storing water within their own bodies. In regions where droughts can strike unexpectedly, certain trees have adapted to survive by holding water directly inside their trunks. These living reservoirs can store thousands of liters, enough to sustain the tree and surrounding life through long dry periods. Baobab trees in Africa are among the most famous examples, their massive, swollen trunks functioning like natural water tanks. Animals and humans alike have relied on these trees for survival, cutting into them during times of extreme thirst. In tropical forests, other species also store water within spongy wood tissues, maintaining hidden reserves that stabilize entire ecosystems. When rainfall falters, these trees continue supplying moisture, allowing life to persist. Touching such a tree is like touching a living well, quietly guarding water deep within its fibers. In this way, trees are not just plants, but protectors of hydration, embodying resilience in environments where water can mean the difference between survival and collapse. Forests also store more fresh water than all the world's lakes combined. While lakes and rivers are the most visible sources of fresh water, forests hold vast quantities hidden beneath the surface. Tree roots help draw water into the soil, while forest canopies slow rainfall, allowing it to seep gently into the ground rather than washing away. Wetlands and peatlands lock water into mosses and saturated soils for centuries, creating enormous underground reservoirs. These hidden stores surpass all surface lakes combined, making forests essential components of the global water cycle. Every drop that filters through leaves and roots becomes part of a system that supplies drinking water, irrigation, and climate stability for billions of people. Forests are quietly and persistently Earth's greatest freshwater banks. Forests even influence the chemistry of the oceans. Though they seem worlds apart, forests and seas are deeply connected by rivers and air currents. Nutrients washed from forest soils travel downstream, feeding plankton blooms that form the foundation of marine food webs. Forests also regulate how much carbon dioxide enters the atmosphere, shaping how much dissolves into seawater and affects ocean acidity. Even microscopic particles released by trees, known as aerosols, drift across oceans, influencing cloud formation, rainfall, and salinity. In this sense, forests help choreograph the chemical balance of the seas. The health of the ocean begins far inland, beneath the shade of trees and within the soil of distant forests. Trees can even change the chemistry of rain itself. Rain falling through a forest canopy is transformed as droplets brush against leaves, bark, and moss. Along the way, the water absorbs organic acids, sugars, nutrients, and antimicrobial compounds released by trees, By the time it reaches the ground, its chemistry is altered, nourishing soil microbes or suppressing harmful pathogens. Scientists call this process throughfall, and it creates a unique chemical signature for each forest. This enriched rain fertilizes the forest floor, supporting seedling growth and shaping plant competition. Trees do not merely receive rain. They actively modify it, turning every storm into a conversation between canopy and soil. In some tropical forests, rivers turn dark from leaf chemistry alone. Blackwater rivers, especially common in the Amazon, appear brown or nearly black due to tannins leached from decaying leaves and plant matter. As rainwater flows through forest soil, it absorbs these natural compounds, staining the water like brewed tea. These rivers are low in nutrients but incredibly clear, supporting species uniquely adapted to their chemistry. Fish, insects, and plants in blackwater rivers differ greatly from those in nearby sediment-rich waters, creating a mosaic of aquatic worlds. Drifting along such a river feels eerie and peaceful, as if the forest itself has melted into the water, coloring it with the memory of fallen leaves. Even forest leaves can carry traces of distant oceans. Tiny salt particles lifted from crashing waves can travel hundreds or even thousands of miles on the wind before settling on inland forests. Scientists have discovered microscopic traces of ocean salt on leaves far from any coastline. These particles sometimes become part of the chemical exchanges between trees and rain, linking forests to seas across vast distances. It is a quiet reminder that Earth's systems are never isolated. The forest listens to the ocean responds to the forest, and life continues in a web of invisible connections. These tiny particles drifting through the air may seem insignificant, but they can influence how leaves absorb water and how they interact with sunlight throughout the day. Some particles settle gently onto leaf surfaces, subtly altering how moisture spreads across the waxy skin of the foliage, or how heat is reflected or absorbed. Others act as catalysts, serving as starting points for chemical reactions that occur in the atmosphere above the forest canopy. These reactions can affect cloud formation, rainfall patterns, and even local climate behavior. The connection is delicate, almost invisible, yet profoundly important. Forests are not sealed worlds. They breathe not only their own air but also faint whispers carried from distant oceans. In microscopic form, every leaf may hold a reminder of waves crashing on faraway shores, a silent exchange between sea and forest happening high above the ground. Leaves in a forest can also change color without the arrival of autumn. In temperate regions, we usually associate shifting leaf colors with fall, a predictable seasonal transformation. But in tropical forests, leaves can change hues at any time of year. Newly formed leaves often emerge in shades of red, bronze, or orange, acting as a natural sunscreen that protects delicate tissues from intense sunlight until the leaf fully matures. Other species alter their color as a signal, possibly to attract pollinators or to discourage insects that mistake young leaves for food. At times, entire sections of the canopy can suddenly glow with streaks of red, purple, or yellow, even though no season has changed. This constant turnover of color is one reason tropical forests appear endlessly vibrant. The shifting palette is not driven by cold or shortening days, but by survival strategies written directly into the biology of leaves. At any moment, the forest pulses with quiet flashes of color, reminding us that transformation is not bound to seasons alone. Forests also play a powerful role in shaping the migration of birds across the planet. For countless species, forests are not just permanent homes, but essential waypoints on epic journeys that span continents. Migratory birds depend on forest habitats as resting and feeding grounds, places where they can recover strength during flights that may cross oceans, deserts, or mountain ranges. The presence or absence of forests along these routes often determines whether a migration succeeds or fails. Some forests produce fruit precisely when birds arrive, fueling their next leg of travel. Others provide shelter from predators, storms, and exhaustion. Even species that do not live in forests year-round rely on them during these critical moments. When forests disappear, entire migratory routes can collapse, breaking ancient patterns written into instinct. To hear birdsong in spring is to hear voices shaped by forests far beyond the horizon, echoes of journeys made possible by distant trees. In African forests, elephants are among the most influential architects of the ecosystem. In the Congo Basin, forest elephants shape the land simply by moving through it. Their massive bodies push through dense undergrowth, opening pathways that allow sunlight to reach the forest floor. As they feed on fruit, they swallow seeds and carry them for miles before depositing them in nutrient-rich droppings, creating perfect conditions for new growth. Some tree species rely entirely on elephants, requiring passage through their digestive systems before seeds can germinate. Over decades and centuries, elephants influence which trees thrive, how dense the forest becomes, and how light filters through the canopy. Without them, some forests would become overgrown and imbalanced, while others might lose entire tree species. Forest elephants are not merely inhabitants. They are engineers shaping the structure of their world, proving that animals and trees are deeply intertwined in the ongoing construction of forests. Many forests are also maintained by bats and birds acting as tireless seed carriers. Forests do not regenerate on their own. They rely on countless animal partners. Fruit-eating bats travel long distances at night, dropping seeds as they fly, spreading forests across landscapes far beyond the reach of any single tree. Birds perform a similar role during the day, scattering seeds in their droppings after feeding on berries and fruit. In some regions, bats are responsible for more than 90% of new seedlings after disturbances such as fires or logging. Birds help maintain diversity by ensuring seeds reach a wide range of environments. Without these flying helpers, forests would shrink and fragment, unable to heal themselves effectively. Every wing beat in the night sky and every call at dawn contributes to a cycle that allows forests to persist and expand. In some African forests, birds even guide humans to hidden sources of food. The greater honey guide is known for its extraordinary partnership with people. These birds intentionally lead humans to wild beehives concealed deep within forests. They call for attention, then fly ahead, stopping periodically to ensure they are being followed. Once the hive is found and humans collect the honey, the birds feast on the leftover wax and larvae. This cooperation has existed for thousands of years and is one of the rare cases where wild animals and humans communicate deliberately for mutual benefit. For forest-dwelling communities, the honey guide is both ally and companion, demonstrating that forests are places of unexpected alliances that cross species boundaries. No forest rivals the Amazon in sheer diversity of life. Covering more than 5 million square kilometers, it contains over 16,000 tree species and an astonishing array of animals, insects, and fungi. Scientists estimate that 1 out of every 10 known species on Earth lives within its boundaries. Each layer of the forest supports different life forms, from monkeys and birds in the canopy to jaguars, snakes, and insects in the understory, and fish and dolphins in its rivers. New species continue to be discovered regularly, even today. In some areas, a single square kilometer contains more plant species than all of North America combined. The Amazon is not merely a forest. It is Earth's living archive of biodiversity, a library still being explored page by page. Some forests remain so remote that they are barely explored at all. Despite satellites mapping the planet, vast areas of dense forest in places like Papua New Guinea, the Congo Basin, and isolated Amazonian valleys remain largely untouched by scientists. These regions are difficult to reach due to swamps, thick vegetation, and extreme remoteness. Researchers believe they may contain thousands of undiscovered species. To the modern world, these places appear as blank spaces on maps, yet life thrives there uninterrupted. They remind us that even in an age of technology, Earth still holds deep mysteries. In certain floodplains and wetlands, forests grow on floating mats of vegetation. These mats form when roots and soil intertwine tightly enough to create buoyant platforms. Trees and shrubs take root on top, forming drifting forests known as suds in Africa or floating meadows in South America. These ecosystems move slowly with currents and wind, constantly shifting position. Fish feed among dangling roots, birds nest in dense greenery, and humans sometimes use them as grazing land. Walking on one feels surreal, like standing on living ground that sways beneath your feet. These floating forests blur the boundary between land and water, existing in a perpetual state of motion. A forest adrift, alive and wandering. There are forests growing far beneath the surface of the ocean, reminding us that forests are not limited to dry land alone. Beneath rolling waves and shifting currents, vast kelp forests rise from the ocean floor, anchored firmly by strong, root-like holdfasts that grip rock and reef. These towering algae can grow to astonishing heights of more than 100 feet, forming dense underwater canopies where sunlight filters down in shimmering beams, much like it does through the leaves of a forest on land. In this submerged world, fish weave effortlessly among the long, flowing fronds, while sea otters hunt for sea urchins and seals dart swiftly through the green corridors. Just like terrestrial forests, kelp forests create shade, shelter, and an abundance of food, making them some of the most productive ecosystems on Earth. Along coastlines in places such as California and Chile, they support fisheries, sustain livelihoods, and protect shorelines by softening the force of powerful waves. Though they are not made of trees, their structure and ecological role mirror land forests so closely that they are often described as their oceanic equivalents. These underwater forests remind us that the idea of a forest extends far beyond soil and roots, thriving even in the restless blue depths of the sea. Some forests grow in places shaped by fire and instability, resting on the slopes of active volcanoes. In countries such as Indonesia, Japan, and Costa Rica, forests cling to volcanic mountainsides, flourishing in landscapes that are both fertile and dangerous. Volcanic soils, enriched by minerals released during past eruptions, are among the richest on Earth, allowing lush vegetation to take hold. Yet these same landscapes are constantly threatened by eruptions, ashfall, and flowing lava. Plants are often the first to return after an eruption, quickly colonizing fresh lava flows by sending roots into cracks and fractures, beginning the slow process of renewal. Animals soon follow, reclaiming the land even as the risk beneath their feet remains. Forests on volcanic slopes stand as powerful symbols of resilience, showing that life does not merely recover from destruction, but often depends on it. Each eruption resets the landscape, turning devastation into fertility and laying the groundwork for rebirth. These forests exist in a delicate balance, both fragile and fierce, endlessly rebuilding themselves on the edge of Earth's fire. Some forests have shaped not only ecosystems, but human imagination itself. Germany's Black Forest, with its towering pines, deep shadows, and mist-filled valleys, has long stirred feelings of mystery and unease. Its atmosphere inspired some of the world's darkest fairy tales, influencing the Brothers Grimm as they recorded stories of witches, wolves, and children lost among the trees. For centuries, the forest's isolation and gloom made it a backdrop for myths of danger and magic. Yet beyond these stories, the Black Forest is alive with vibrant wildlife, clear streams, and picturesque villages nestled among the trees. What people once perceived as dark and threatening was, to the animals that lived there, simply home. The Black Forest reminds us that our relationship with forests is not only biological, but deeply cultural. Forests shape our stories, our fears, and our sense of wonder, becoming places where imagination and ecology intertwine. Some of the oldest forests on Earth no longer live, but remain preserved in stone. Long before humans walked the planet, forests flourished across prehistoric landscapes, and in rare cases, they left behind fossilized remains. Petrified forests found in places such as Arizona, Argentina, and even Antarctica are made of ancient trees that slowly turned to stone over hundreds of millions of years. Minerals replaced the organic material cell by cell, preserving remarkable details, from growth rings to bark textures. These stone forests reveal what Earth's ecosystems looked like in distant eras, including species that no longer exist. Some fossils are so exquisitely preserved that scientists can study microscopic structures within them. Walking among these petrified trunks feels like stepping through time itself, where trees lie frozen mid-growth, silent and unchanged. They remind us that forests are ancient beyond imagination, spanning entire epochs, their roots reaching not only into soil, but into the deep history of life on Earth. While deforestation remains a global concern, forests are not disappearing everywhere. In fact, forests are expanding in some parts of the world. Across regions of Europe, North America, and China, tree cover is increasing. This regrowth often occurs where farmland has been abandoned or where large-scale reforestation efforts have taken hold. In Europe, centuries-old agricultural lands are slowly being reclaimed by trees. In China, massive planting campaigns have added billions of new saplings to the landscape. Although these recovering forests may lack the complexity of ancient ones, over time they begin to restore soils, attract wildlife, and capture carbon from the atmosphere. Their return offers hope, showing that ecosystems can recover if given time and protection. Forests, though fragile, are also remarkably resilient, capable of returning to places where the sound of wind through branches had been absent for generations. In some regions, forests are even growing where deserts once spread. Across parts of Africa, Asia, and the Middle East, trees are beginning to rise from lands that were once barren. This transformation is often driven by intentional restoration efforts aimed at combating desertification. In northern China, the Great Green Wall project involves cultivating millions of trees to slow the advance of the Gobi Desert. In Africa's Sahel region, communities plant native species adapted to dry conditions, helping restore soil, create shade, and bring back water. Nature also plays its part, as shifts in rainfall and climate open new opportunities for growth. While these young forests may not yet rival ancient rainforests, they stand as living proof that deserts are not always destiny. With patience and care, even the driest landscapes can bloom once again. Some of the world's rarest forests exist only on tiny islands scattered across vast oceans. Island forests such as Hawaii's cloud forests, the dragon blood tree groves of Socotra, and the palm forests of the Seychelles exist in fragile isolation. These habitats are often home to species found nowhere else on Earth, shaped by millions of years of evolution in separation from the rest of the world. Because these forests are so limited in size, even small disturbances can have dramatic effects. A single storm, invasive species, or human settlement can permanently alter them. Yet their rarity makes them biological treasures, living museums that showcase evolution's creativity. To walk among them is to witness life that exists nowhere else. Forests as rare and delicate as jewels scattered across the oceans. Not all forests are vast expanses stretching across continents. Some of the world's smallest forests are only a few trees wide. In certain places, a cluster of trees just a few dozen meters across qualifies as a forest. These miniature forests may grow in valleys, along rivers, or atop isolated hills. Despite their small size, they often support surprising levels of biodiversity. Birds, insects, and small mammals treat these patches as vital refuges within otherwise open landscapes. Scientists have found that even the tiniest forests help store carbon, regulate water, and protect soil. For nearby communities, they can provide shade, food, and cultural meaning. These small forests remind us that size is not what defines a forest's importance. Even a handful of trees can carry the spirit and function of a forest, proving that resilience and wonder exist at every scale. Some forests are defined by the species that exist nowhere else within them. Isolation creates uniqueness. Forests separated by mountains, rivers, or oceans often become homes to plants and animals found in no other place on Earth. Madagascar's forests shelter lemurs and towering baobabs unlike anything seen elsewhere. Australia's eucalyptus forests support marsupials and birds shaped by long isolation. Even small forest patches can protect rare insects or plants that never spread beyond their boundaries. These species are often fragile and highly vulnerable to extinction if their habitats disappear. Yet their existence highlights the extraordinary creativity of evolution, sculpting life to fit local conditions. Every forest becomes a stage for experiments millions of years in the making, many of which unfold in only one corner of the planet. To step into such a forest is to enter a world entirely its own, where every species carries the story of place written into its very being. Forests are not passive landscapes when it comes to weather. In many ways, they can seem to create their own forecasts, quietly offering clues about what is to come. Scientists who study forests have discovered that subtle changes in leaf chemistry, shifts in humidity beneath the canopy, and even patterns in insect movement can signal approaching changes in rainfall or temperature long before those changes arrive. Long before modern instruments existed, indigenous communities around the world learned to read these signs with remarkable accuracy. They understood that certain bird calls, insect behaviors, or the blooming of specific trees often meant storms were near or seasons were shifting. In this sense, forests appear to forecast their own weather, responding to delicate atmospheric changes almost like living sensors. As trees release water vapor and chemical compounds into the air, they actively influence cloud formation above them, creating feedback loops that help shape local weather patterns. To walk through a forest is to step into a natural barometer, where every scent carried on the wind, every shimmer of leaves, and every shift in sound holds hints about tomorrow's skies. When night falls, forests often become louder than cities. As the sun sets and human activity fades, many forests do not fall silent at all. Instead, they awaken with sound. Frogs croak from hidden pools, insects hum relentlessly, owls call through the darkness, and mammals rustle through the underbrush. In tropical forests especially, the combined chorus of nocturnal life can exceed the noise levels of busy urban streets. Scientists who record forest soundscapes at night frequently discover layers upon layers of sound, from deep, low rumbles to piercing high-pitched chirps, each occupying its own frequency range like instruments in a vast orchestra. This nighttime noise is not chaos. It is communication, competition, mating calls, and survival unfolding through sound. For humans, the experience can feel overwhelming or even disorienting, a reminder that the forest never truly sleeps. Its voice simply changes, shifting from the bright chatter of daytime birds to the deep, pulsing music of night. The soundscapes of forests transform dramatically from dawn to darkness. From the first pale light of morning to the stillness of midnight, forests move through sound cycles as complex and deliberate as any symphony. Morning often begins with an explosion of bird song as countless species greet the rising sun. As the day warms, insects take over, their buzzing and clicking filling the air. Afternoon rains may arrive, drumming rhythmically on leaves and branches, followed by renewed bird calls once the storms pass. At dusk, frogs begin their chorus, soon joined by nocturnal mammals and insects. Each layer of life claims its own time and rhythm, weaving a continuous soundtrack that evolves hour by hour. Scientists studying these sound cycles have found that forest soundscapes are carefully partitioned rather than random. Each species adapts its timing to ensure it can be heard without being drowned out. To listen to a forest across an entire day is to hear its heartbeat, measured not in silence, but in waves of living sound. In many forests, insects are the true musicians. Cicadas, crickets, and countless other species produce constant choruses that create a background hum rising and falling like breathing. Some cicada species emerge in synchronized waves, flooding entire landscapes with deafening songs that can be heard miles away. Others sing nightly, overlapping their rhythms in intricate patterns that scientists often compare to music. These insect choruses serve vital purposes, attracting mates, marking territory, and confusing predators. For humans, they become the defining sound of warm nights beneath the trees. While birds and mammals may come and go, insects keep the soundtrack steady, a ceaseless pulse marking the forest's life through vibration and hum. Without them, the forest would feel strangely hollow, stripped of its constant living music. Some forests hold secrets that reach back to the earliest chapters of life on Earth. Certain ancient forests preserve traces of evolutionary history stretching hundreds of millions of years into the past. In places like Canada's Mistaken Point and other fossil-rich sites, imprints of primitive organisms appear in what were once vegetated landscapes. Even today, untouched forests contain genetic lineages that trace back to prehistoric times. Cycads, often described as living fossils, still grow in tropical forests, much as they did when dinosaurs roamed the planet. These remnants link modern ecosystems to ancient ones, bridging the vast gulf of time. Within their leaves, spores, and seeds lie clues to how life diversified, adapted, and endured. Forests are not only alive in the present moment, they are living archives of Earth's deep past, holding stories that science is only beginning to fully understand. Beneath every forest lies a hidden world as vast and complex as the canopy above. The roots of trees interlace underground, forming immense networks that can stretch for miles. In mangrove forests, roots extend into rivers and seas, stabilizing shorelines while reaching deep into sediment in search of nutrients. In temperate forests, roots often connect trees together, allowing them to share water and minerals. These underground connections are strengthened by fungi, forming what scientists call the wood wide web. Through this network, trees can exchange sugars, send chemical signals, and even warn one another of danger. This means a forest is not simply a collection of individual trees, but a community bound together by living threads beneath the soil. Though unseen, these roots are as vital as trunks and leaves, binding the forest into a single organism that grows, communicates, and survives as one. Forests are also arenas of quiet chemical warfare. Many trees produce their own natural insect repellents to defend themselves from the billions of insects that feed on leaves and bark. Eucalyptus trees release aromatic oils that repel pests and even inhibit the growth of competing plants. Pine trees ooze sticky resin that traps insects while releasing sharp scents that act as warnings. Some species adjust their chemical defenses depending on the season or the severity of the attack. These natural repellents are so effective that humans often borrow them, using forest-derived oils and compounds in medicines and insect deterrents. Every breeze carrying the scent of pine or eucalyptus is more than a pleasant fragrance. It is a defensive shield woven into the forest itself. Trees also defend one another. They are not silent victims when grazed by animals. Studies in African savannas have shown that when giraffes feed on acacia leaves, the trees release chemical signals into the air. Nearby acacias detect these signals and rapidly increase bitter tannins in their leaves, making them unappealing to herbivores. In this way, entire groves coordinate their defenses, protecting one another from overgrazing. This behavior reminds us that trees are active participants in their ecosystems, capable of rapid and coordinated responses. The forest behaves less like a collection of individuals and more like a single organism working to maintain balance. In some forests, trees even appear to heal one another. When a tree is damaged, neighboring trees sometimes send sugars and nutrients through underground root and fungal networks to sustain it. Even ancient stumps, incapable of photosynthesis, have been found alive for centuries, nourished by surrounding trees. Scientists believe this sharing helps stabilize forests, preserve root systems, and prevent erosion. It suggests that forests prioritize collective survival over individual competition. A forest is not merely a group of trees standing side by side. It is a living community where strength is shared and survival is mutual. Forests are often called the lungs of the planet because they absorb carbon dioxide and release oxygen. But this metaphor captures only a fraction of their importance. Forests regulate rainfall, stabilize soil, cool the air, and support biodiversity on a staggering scale. They influence weather patterns across continents and shape the global carbon cycle. They provide food, medicine, shelter, and cultural meaning for countless species, including humans. To call forests lungs is to overlook their broader role. In truth, they function more like the heart, brain, and circulatory system of the Earth combined. They keep the planet alive in ways far beyond breathing, acting as regulators of climate and guardians of life's incredible diversity. A forest is never just a collection of trees standing side by side. Every forest functions like a planetary system in miniature, quietly influencing the world far beyond its visible boundaries. Within its roots, trunks, and canopies, a forest regulates water, stores energy, shapes climate, and records time itself. What appears to us as a peaceful landscape is, in reality, a living engine constantly interacting with the planet on scales both local and global. Some trees possess an extraordinary ability. They record centuries of climate history within their own bodies. Each year of a tree's life is marked by the formation of a growth ring. In years of drought, these rings grow narrow and dense. In years of abundant rainfall, they expand wider. Over decades, centuries, and even millennia, these rings accumulate into an astonishingly precise archive of environmental conditions. By reading them, scientists can reconstruct patterns of rainfall, temperature shifts, and even evidence of ancient volcanic eruptions that occurred long before written history existed. Certain ancient trees contain over 1,000 years of climate data sealed within their trunks. This field of study, known as dendrochronology, allows researchers to understand how forests and the Earth itself have responded to past environmental changes. Trees are not merely witnesses to time. They are archivists, preserving memory in wood. Every trunk becomes a living timeline, carrying the story of Earth's changing climate across generations. Forests influence Earth's climate far more deeply than many people realize. Their role extends well beyond absorbing carbon dioxide. Trees release vast amounts of water vapor into the atmosphere, which rises and helps form clouds that cool the planet by reflecting sunlight back into space. The color and structure of forests also matter. Dark canopies absorb heat, while lighter forests reflect more solar radiation. Beyond this, trees emit chemical compounds that seed cloud formation and influence rainfall patterns thousands of miles away. The Amazon rainforest, for example, plays a critical role in maintaining weather systems that affect regions as distant as North America. When forests are cut down, it is not only stored carbon that is released. Entire climate-regulating systems are disrupted. Forests are not passengers in Earth's climate journey. They are drivers, actively shaping temperature, water cycles, and atmospheric balance across continents. Recent research suggests forests may be cooling the planet even more than scientists once believed. In addition to carbon absorption, forests generate a powerful natural cooling mechanism through the release of water vapor. This process, known as evapotranspiration, functions like a vast biological air conditioning system, capable of lowering regional temperatures by several degrees. Forests also increase cloud cover, which further reflects sunlight and prevents overheating. Together, these effects may offset more warming than previously estimated. In a world facing rising temperatures, forests are not only victims of climate change. They are among our strongest allies against it. Every tree contributes to this invisible global cooling network. The shade we feel beneath a single tree is only a faint hint of the immense planetary-scale cooling forests provide every day. Every forest exists simultaneously in the past and the present. Forests are paradoxes of time. Some trees standing today may be hundreds or even thousands of years old, while new saplings push upward from the soil each season. Beneath the forest floor lie remnants of forests that existed millions of years ago, compressed into soil and stone, while above ground, young leaves prepare the canopy of the future. In this way, every forest is both an archive and a frontier, ancient in its roots yet new in its growth. Walking through a forest means moving through overlapping generations, where life cycles blend and time feels layered rather than linear. Forests are never frozen in history. They are always in motion, holding the past while continuously growing the future. Despite centuries of study, forests still conceal mysteries we have yet to uncover. Each year, scientists discover new species of plants, insects, fungi, and microorganisms, many of them hidden in plain sight. The full extent of how trees communicate, the role of fungi in shaping ecosystems, and the complete influence of forests on global climate remain only partially understood. Even the total number of species living in vast regions like the Amazon or the Congo Basin is still unknown. In many ways, forests remain frontiers as mysterious as deep oceans or outer space. They hold unanswered questions about evolution, cooperation, and survival. Every step beneath a forest canopy is a step into the unknown, a reminder that mystery thrives even in landscapes we believe we understand. Some forests contain trees that appear to bleed. In regions of Africa, South America, and Asia, certain tree species release sap so vividly red that it resembles flowing blood. The most famous example is the dragon blood tree of the island of Socotra, whose deep crimson resin has been used for medicine, dyes, and rituals for thousands of years. When its bark is cut, thick red liquid pours from the wound, giving the tree an almost mythical presence. Other species, including some eucalyptus trees, also produce red-tinged sap. To ancient cultures, these trees seemed alive in an especially powerful way, as though their lifeblood was visible. Today, scientists study these resins and discover that they contain antibacterial and protective compounds. What appears eerie or unsettling is actually a tree's method of sealing injuries and defending itself. Even in silence, forests bleed, heal, and endure. Some rainforest trees grow to heights that rival human monuments. Deep within the Amazon, certain trees have been measured at over 80 meters tall, rising higher than the Statue of Liberty. Species such as Dinizia excelsa tower above the surrounding canopy, capturing sunlight where few others can reach. These giants act as vertical worlds, hosting entire communities of birds, insects, and epiphytes within their branches. Their immense size allows them to store vast quantities of carbon, strengthening the forest's role in regulating climate. Standing beneath one inspires the same awe as gazing at a skyscraper, with one crucial difference. This structure is alive, ancient, and rooted directly into the earth. The largest known tree by volume stands in California's Sierra Nevada. The General Sherman tree, a giant sequoia, holds the title of the most massive tree on Earth by volume. Its trunk alone contains over 1,000 cubic meters of wood, making it heavier than dozens of blue whales combined. Yet it is neither the tallest nor the oldest tree, reminding us that forests hold many different kinds of giants. Its immense volume is the result of thousands of years of steady growth, layer upon layer forming a monument of living tissue. Standing before it, humans seem impossibly small. This single tree functions like a forest unto itself, hosting mosses, birds, insects, and countless microorganisms, all sustained by one living being that has endured for over 2,000 years. Among the fastest-growing plants on Earth, bamboo represents speed and resilience. Certain bamboo species can grow nearly a meter in a single day, fast enough that the movement is visible over time. This rapid growth allows bamboo forests to recover quickly after harvesting or natural disturbance, making them essential renewable resources in many parts of the world. Bamboo's hollow yet flexible structure gives it exceptional strength, qualities humans have used for thousands of years in construction, tools, textiles, and paper. In forests, bamboo provides shelter and food for many species, including the iconic giant panda. Its rapid expansion also stabilizes soil and reduces erosion. Bamboo's speed is not just remarkable, it is a survival strategy, allowing it to compete successfully in dense ecosystems. Over millennia, forests reshape entire landscapes. They are not passive backdrops to geological processes. Tree roots slowly crack rock into soil. Fallen leaves build thick layers of fertile ground that nourish future generations. Forests capture rainfall, guide rivers, and sometimes redirect their flow entirely. In regions such as the Amazon basin, forests recycle their own moisture, creating conditions that sustain the landscape itself. Over thousands of years, forests have transformed barren volcanic slopes into lush ecosystems and carved fertile plains from rocky ground. These changes occur so slowly that they escape human notice, yet they fundamentally alter the face of the earth. Forests do not merely exist on the planet, they shape it. Yet they mark one of nature's most powerful forces, life itself, shaping the planet over immense stretches of time. Life does not always announce its power through violence or speed. Often it works quietly, patiently, pressing forward year by year, root by root, cell by cell. Forests stand as proof that the slow accumulation of living processes can reshape continents, alter climates, and redefine landscapes. What appears gentle on the surface is, in truth, one of the most enduring forces Earth has ever known. The Amazon River was once a swampy forest. Before it became the vast, flowing artery we recognize today, the Amazon basin existed as a sprawling inland world of wetlands, shallow lakes, and dense swamp forests. Around 10 million years ago, tectonic shifts deep within the Earth caused the Andes Mountains to rise, blocking water that once flowed freely toward the east. With nowhere to escape, water pooled across the basin, transforming the region into an enormous, waterlogged forest where land and river blurred into one. Fossil evidence reveals that this ancient swamp supported extraordinary life. Crocodiles grew to the length of buses, massive turtles moved through dark waters, and towering vegetation thrived in the warm, saturated environment. These forests were not quiet places. They were alive with movement, sound, and competition. A prehistoric world shaped equally by water and wood. Over millions of years, as the Andes continued to rise and pressures slowly shifted, the trapped waters finally broke through. They carved channels that deepened, widened, and eventually formed the modern Amazon River. Even today, the forest remembers this past. Seasonal floodplains still swell each year, wetlands expand and contract, and vast stretches of forest spend months submerged. The Amazon is not simply a river bordered by trees. It is the result of forests and water shaping one another across deep time, locked in an ancient partnership that continues to evolve. Some forests are shaped by seasonal floods. In regions such as the Amazon and parts of Southeast Asia, water rises predictably each year, sometimes by several meters, transforming solid ground into temporary waterways for months at a time. What might seem destructive instead becomes a defining rhythm of life. Rather than drowning, trees adapt in remarkable ways. Some grow hollow or porous stems that allow oxygen to reach submerged tissues. Others develop specialized roots capable of surviving long periods underwater. These flooded forests become temporary aquatic worlds, where fish swim between tree trunks and aquatic animals find shelter among branches. When floodwaters finally retreat, they leave behind nutrient-rich sediments that fertilize the soil. Growth surges. Life accelerates. To exist in these forests is to accept constant transformation, a cycle of submersion and renewal where stability comes not from stillness, but from adaptability. These ecosystems show us how flexible life can be, thriving under conditions that appear impossible to endure. Forests once covered nearly the entire Earth. Hundreds of millions of years ago, before vast deserts formed and before polar ice caps existed, forests blanketed almost all of Earth's land surface. During the Carboniferous period, immense swamp forests of giant ferns and towering trees dominated the planet, slowly creating the coal deposits we rely on today. Later, endless coniferous forests stretched across ancient supercontinents, unbroken for thousands of miles. These forests transformed the atmosphere itself. Oxygen levels rose dramatically, enabling the existence of giant insects, amphibians, and unfamiliar forms of life. Over time, shifting climates and drifting continents fractured these green expanses, leaving behind the mosaic of ecosystems we see now. Still, the memory remains. Earth was once almost entirely forest, a green world ruled by trees. Forests will outlast most human structures. Cities, monuments, and highways may feel permanent, but forests quietly remind us of time's true scale. When human presence fades, trees return. Roots fracture concrete. Vines crawl through windows. Branches shade collapsed walls. Even the grandest temples and fortresses eventually yield to steady growth. Forests move slowly, yet their persistence is unmatched. They have outlasted civilizations before and will likely outlast many still standing. Human permanence is measured in centuries. Forest permanence is measured in millennia. When left alone, forests erase scars and reclaim space, not through force, but through patience. Forests remind us that life is both fragile and fierce. They can burn, wither, or disappear within a single generation, their vulnerability exposed on every cleared hillside. And yet, they have survived ice ages, storms, and the rise and fall of empires. A seedling may be crushed underfoot, but given time, it can become a giant. Entire forests may fall, and decades later return, alive once more. As we come to the end of our long journey through Earth's forests, I hope you felt the calm of walking beneath their canopies, even if only in your imagination. From towering redwoods reaching skyward, to hidden fungal networks beneath our feet, to the silent stories written in every tree ring, forests reveal how intricate and enduring life can be. They are fragile and fierce, ancient and new, mysterious and familiar. And while they may seem distant, forests are never far. Every breath of air, Every sip of water, every heartbeat owes something to them. They are the living memory of our planet, and its hope for the future. If you've enjoyed this journey, I'd be grateful if you considered liking and subscribing to the Science for Sleep channel, or leaving a gentle thought in the comments. Each small gesture helps others find their way here. For now, there is nothing more you need to do. Let your breathing soften. Let your body grow heavy against the bed. Let the quiet presence of forests linger in your mind like a sheltering canopy. Sleep comes easily when we let go. Tomorrow will wait. Tonight belongs to stillness. And when you wake, the forests and the next story will be waiting. Good night.